Hello team, today's challenge is number words, where we're given a number and we need to convert it to its string equivalent, its expanded form. So right here we have 0, we're going to return the word 0. We have 19, we're going to return the word 19, and so on, etc. There is some tricky business down here where we get into a dash when we have to do that, but we can take care of all that. Quite a few ways to do this. So there are some libraries out there that you could use. They come with a lot of extra stuff, right? Or we could just knock it out with a series of conditionals. Today, I'm going to use a little bit of the second, and some recursion to get this done, because I think this actually works well with recursion. You'll see in a second here, okay? So right here, I have taken the liberty of creating my my numbers, okay? These are the unique numbers. So we have the 0, we have 1 to 9, we have the teens, and then we have the divisible by tens. Okay, that just gets us a head start. We aren't going to try and worry about anything like that. And then we are going to use a combination of these to get our final output. Later on, I also have a thing where we'll talk about going to hundreds and thousands. Okay, so we'll touch on that briefly as well. I forgot a space here. Going to go fix that because I can. Okay. I used a map for quick lookups, right? And because you can see that I don't need each individual thing in here, right? It just makes it easier for me. So that helps me. With that, we can go down here. Okay. And the first thing that we're going to check is to see if the number is greater than 100. Okay. If it is greater than or equal to 100, we should throw an error. We should not do anything. We'll come back to this part in a second, but let's just stay with the original challenge for a second. So if n is greater than equal to 100, throw new error and something like too big, right? Seems pretty simple. The second conditional I want in here is to see if our number already exists in here. If it does, we don't have to do any sort of work. We don't have to pass through any of the other stuff that comes next. So let's just return it, right? If it already exists, we can do that. And that looks like this. We have that, that number map. So number map dot has, because it's a map, n. If it does, then just return number map dot get n, okay? And if I hit this, if I run it, you'll see that most of our tests already pass because they've used some very simple numbers in here. We didn't have to do anything fancy. In fact, it's just these 3 that are giving us problems that we'll have to work through, specifically the 3 with the dash. So we need to figure that out because they are not in our map, right? So let's go and do that. That is going to be down here, and we are going to start out by getting the exponent. This one sounds funny, but stay with me for a second. It's going to be the exponent of the first digit. So if we had the number 100, right? The first digit of 100 is this 1. If we had 53, like on the other page, the first digit is 5. And that's what we're looking for here with this exponent part. Okay, so we're going to start by getting this. And for that, we use log 10. Now, log 10 is an interesting one. Okay, what it does is it gives us, I forgot the equal sign. That's so weird. Is it gives us how many, it gives us the power of 10 that gets us back to n. So as an example for 100, if we did mathlog 10 100, it would give us 2, right? Which is 10 to the power of 2. 10 squared is 100, right? If we did 1,000, it would be 10 to the 3, right? It would mathlog 10 would return 3. 10 to the 3 is 1,000, which is why we have 2 and 3 up here that we'll end up using later, okay? The problem is that it will return a float. We do not want a float. In fact, we want to floor that, okay? So we have 2 options here. We can go math.floor, or we can go math.trunk, okay? Either one of those will work today. They are slightly different, but for what we're doing, it doesn't matter, okay? It really doesn't. Now, here we're going to get the power. Power is probably the wrong number, the wrong name for this, because the exponent is technically the power. But what we're getting is the return from expanding our exponents back out, okay? So right here we have 10 to the power of exp, right? And that will give us whatever that should have been. So it'll give us 10 or 100 or 1000 or 10,000, whatever it is, right? Whatever that exponent was, 10 to the power of that, that's our power, because that tells us what the largest number is, okay? We'll use that in a bit. One more thing, we need the, what I'm going to call the big number. I guess I could have called it first digit, actually. It's probably a better one, okay? And that is n divided by power, okay? So whatever that first digit is if we had 100, 100 divided by 10 squared, which is 100, 100 divided by 100 is 1, which is what this is, right? So if it was 500, 500 divided by 100 is 5, right? It all just sort of works out. Again, this could deliver a floating number. So we're going to do the same thing where we go math.trunc, okay? At this point, we have a lot of information in here that helped us get to this first number. We are going to come back to exponent in a second, but everything is about this first number. And that's really important, because what comes next is the return, okay? So right here, I'll do it as a template literal. You could do the plus concatenation if you wanted to. All works, okay? But right here, inside of here, we have that number map, okay? Number map dot get, and what are we getting? Well, it's going to be that first digit, which I am totally going to misspell as big number because that's how I practiced it. But first digit times power. This one feels weird, so let me explain it, okay? First digit, basically we went and got whatever that first digit was, and now we want to expand it out to be the full number. So if it was 1 here, we want to expand it back out to be 100. Could we have just used power? Absolutely. But the problem with power is that that only deals with the 1, right? 10, 100, 1000, so on, etc. And we need whatever this is. If it's going to be 500, if it's going to be 5000, we need that to be in there, okay? So we expand it back out to have our zeros. And that's what this little bit is doing. So we divided by power, we got rid of everything after the decimal place, then we remultiplied by power to get that number followed by a bunch of zeros. Hopefully that's making sense. Between there is a dash, okay? And then the final bit, which is get number words, like this. And what do? Well, we take n modulo power, okay? Which should do it, right? That gets the job done. And basically what's happening here is we have recursion going on, right? So as far down as we can go, we're going to try and return something from inside of here. That's the goal, okay? Whether it's 0, whether it's 90, right? We're going to try and figure that out. And then we are going to attach that to whatever came before it, okay? So some interesting recursion, and it works great. We've solved it, okay? Again, we checked to make sure that it was less than 100 because they're only giving us 1 or 2 digits today, okay? If it is already in our map, we return it so that we don't have to do anything else. We just get past that, return early, get it done, okay? Anytime you can return early, do it, because that is a performance gain. If you have to do a bunch of stuff and then you're returning, not really, okay? But from here, we used some very interesting math, okay? And I had to go and look this one up. I was like, I'm sure that there's something in math. So I'm happy that log 10 is actually in there so that we can do it this way. Did we have to do it this way? No, we didn't, okay? Watch this. If I take this power and I multi-cursor these 3 and just type 10, okay? And then I comment this all out, well, it still passes. And why does it still pass? Because we only have 2 digits, right? And if it doesn't appear Anywhere in this number, it is guaranteed. Once we get down here, it's guaranteed to be 2 digits. Guaranteed. Why? Because, of all things, we cover off all the single digits right here. Okay? So, why did I do all that extra stuff then? If I could have just gone divide by 10, multiply by 10, modulo 10, brilliant. Why? Okay? The answer is this. Okay? We have a working solution here, so it works. But let's say the powers that be came back and they said, you know what? I don't want to just go to 100. I want to go to 10,000. Okay. So the highest number now, not 10,000, but 9,999, right? And we need to make this work. So now we're going to use places. Okay. And the way that works is right here, we're going to set up an if statement. So if n is less than 100, okay, then return. This should still work, not a problem. In fact, all of this is going to continue to work because we don't have tests for this, but I will show you that this works in a second. So stay with me, okay? If we get past this return, so if it was less than 100, we do the normal thing. If we get past this, we're going to return something else. What's it going to be? Well, let's go and grab all of this and make some changes, okay? The first change is that we want only the first digit, because if it is thousands, we have 1,000, 2,000, 3,000, 4,000, right? We have thousands that are preceded by a number. So we want to take care of that, which means that we don't want to do this power anymore. We just want to return the digit. And then from here, we can change this. I'm going to add a space. I don't know if it should be commas or spaces, or we could have those discussions. That's not really the important thing here. Okay, I'm just going to go with a space, and I'm going to add whatever that places is, okay, followed by another space. So it's going to be places, and right here, dot get exp, okay? So remember, the exponent returns how many zeros come after the 1. Basically, that's the long and the short of it. If it's going to be 100, then we get 2 because there are 2 zeros after 100, right? 100. If it's 1,000, right? 3 zeros after 100. So we're gonna reach in here and get the thing. 3 zeros after 1,000. Sorry. Which means that we get the word and we do it. Okay. Double checking my math to make sure that I didn't forget anything. First integer. Yeah. I mean, that's all that we really needed to change, just to go to 10,000. Or 10,000. If we needed to go above 10,000, if we needed to go to 1 million, we probably need another conditional in here, right? But that's something that you can work on in your own time, right? It's very flexible, where we can add extra conditions to this and keep using similar logic to get there, okay? Does this work? I mean, it still works because we don't have any tests, but if we jump over to CodePen, you'll see that I have that right here, okay? So there's our first conditional, which is our normal thing. Here's our return, whoops, jumping ahead. Here's our return for anything over 100, or sorry, over 99, right? It's greater than equal to 100, which means that we do that. And of course, all of our standard tests and a few that I've added. And if I run this and wait a second, it will churn out and we get exactly that. So 100 with spaces, 50, 155, the 55 has a dash in it. Everything else is spaced out. 1,234, 9,999, right? So this works. And again, we could have questions about if there are commas and stuff like that. That's not really important to the challenge, but being flexible is. And I feel like this has done that, okay? So where did we start? Well, we started with a map. Could this have been something else? Could it have been like arrays? I saw one solution where they had all of the single digits as an array, all the teens as an array, all the divisible by tens as an array. Of course you could, right? You could totally do it that way and it gets the job done. So no problems there. an extra little thing just to get 100 and 1,000. Brilliant, not a problem. And then we locked it in, right? We checked to make sure our number wasn't too big. Otherwise, we throw an error. And if our number can be found quickly, then kick it out the door, be done with it. We're done, problem solved. Otherwise, we do a little bit of tricky math in here with log 10, getting the exponents, which returns that very first digit, right? If it's 1,000, it's the 1. If it's 5,000, it's the 5. If it's 20, it's a 2. Okay, whatever that is. I mean, 20 would be caught up here, but hopefully you understand. And then we returned it, right? And then of course we expanded it out to go higher, right? And the whole thing works. That's it. Again, not every solution, just hopefully one good solution. But if you found a different way, let me know in the comments. If you like it, if you hate it, if this is the first time, like me, this is the first time that I've ever used log 10. If it's your first time too, also let me know that in the comments. I love seeing that. Otherwise, this has been Number Words, and I will see you tomorrow.